Welcome everyone to the fourth course. This will be the ending course of the beginner course. We will start with basically how to make 2D simplifications, like 2D axisymmetric simplification of the 3D part, and we will see at the end of this course that how to make a periodic analysis. So let's start with the boundary conditions. This part receives a high pressure from this, and this side. It is held by a thread, which is modeled like this, and basically these are all the boundary conditions. Our job now is to think about the boundary conditions and geometry and determine if this can be simulated axisymmetrically. Due to the fact that our pressure is axisymmetric, our constraints are axisymmetric too. We can make this analysis using the 2D axisymmetric simplification. So let's do it. First, we need to create from this geometry 2D axisymmetric geometry. Ansys structural can only handle this 2D axisymmetric problem if there are no nodes containing smaller y-axis values than 0. So they must be positive. This is true on the x-axis too. So one very important thing, that while in CFD calculations the x-axis is the one that should be used as the axisymmetry, here in the mechanical, the program will only understand the axisymmetry if it will be on the y-axis. So we need to define our problem so it would be axisymmetric on the y-axis. We can do it by rotating our part in the coordinate system. We just need to go to the design tab and find the move thing. Yeah. Click on it, or just like the whole thing. And here it will show you a triad with which you can move the part. But if you would move the part right now, it will move through its axis. So it's no good to us. To fix this, you need to click on this little ball, and you can redefine this triad. And of course, you need to rotate the whole thing by 90 degrees, and basically that's all. And for now, and we need to cut a plane from this 3D part to create this 2D axisymmetric part. You need to go to the Prepare tab, click on the Split by Plane, and split by the plane Z. For example, delete this. Yes, and split by the x-axis too, and delete this guy too. And here we have, basically we can see already that we have here a plane, and to create a surface from it, you need to click Ctrl C, Ctrl V on it, and you can delete the solid body. Let's get back to our simulation. So we need to define first the geometry, 2D geometry. First, we need to define that it's not a 3D, it's a 2D dimension. We need to define the material, which is aluminium, and we need to define that what is the 2D behavior of this part, which is axisymmetric. For mesh, I will choose to use a face sizing, and I will define it with a 2.5 millimeters size. It would be enough. we would define the pressure. Yeah, there's an option that the loaded area would be deformed. I would choose to use the deform because sometimes when there are huge deformations, it would be good if it would follow the surface. Yes, and we should define a fixed support. For this, one might think about using, for example, uh, cylindrical support, but unfortunately for the 2D analysis, there are no support on the cylindrical support. So once we defined it, we basically can continue with solving the problem. Yeah, we can see here the equivalent stresses. It's huge. Yeah, and to visualize, we should insert here a symmetry, and for some of you it might not appear. To make it appear, you need to go back to the workbench, to the tools, options, appearance, scroll down to the bottom, and enable the beta options. So here is under the type, we should choose a 2D Axisymmetric and choose, for example, 28 and 10 degrees. Let's see for first the mesh. Yeah, we see that it revolved. I mean, it's just for the visualization purposes. And let's see the equivalent stress. Yeah. That's all basically with how to do the 2D axisymmetric analysis. So now let's analyze a periodic part. Here we see our periodic part. We see that at the bottom side it has like 6 patterns, and on the upper part it has 12 patterns. So generally speaking, if we would like to make a periodic analysis of it, we are very lucky because we can, based on the geometry, because 6 times 2 it's 12. And when we when it comes to the boundary conditions, basically the boundaries conditions are the a force which comes from on these things, and we have a retention which comes through this holes. So these boundary conditions are periodic too, so we can use them. Let's import this geometry. So open up the space claim and let's make the geometry for the periodic analysis. Once again, I will remove all the edges that are like in my model, which are not needed. And let's try to cut out as many things of our geometry that we need. So again, go to the prepare tab and let's see what could we even with which plane could we even cut anything out from this. So I would really like to choose, for example, yeah, so if we look from the upper end, we see that for one thing like this, we would get free, but not entirely free, but instead we would get one fully and the other two only half. So we could use this, score with this, like, but through the z-axis to cut a little bit out of this, because we see that then we will end up with a little half of it. So now let's cut the other part of it, which will be a bit harder, because we will need to create a plane. So I will create a plane through the Z again, and then move it with the same principles as we did before. And we of course know that with how much do we need to move it, because we have 6 periods, so we need to move it by 60 degrees. And let's cut it with the same technique and just remove it. Yeah, like that. And we can remove the plane even. Now let's get back to our geometry, define the aluminium for it, and let's open the model. Insert symmetry, and on symmetry click, we will insert the symmetric regions. So what symmetric regions is doing, that it defines that where should the basically information not go forward. To define it, we need to create first coordinate systems that will be normal in direction to these surfaces. To do that, insert coordinate system, click on the face that you want to apply it on, click change, apply, and here I usually do it with x-axis, but you can do any axis. I want to define the x-axis direction, which we can do by clicking on to the geometry selection and clicking on the plane. And now we see that our x-axis is normal in direction to the plane. Let's do it with the others too. We can, for example, define this is the second, this is the yeah. Now we should make a coordinate system that looks like this here. Basically, this is called a polar coordinate system. Here we see the basic Cartesian coordinate system too, but we see under it the polar coordinate system too. To do that, go to Insert Coordinate System, and instead of geometry selection, click on the global coordinate systems. Yep, and from the type, choose the cylindrical one. And you can see here that it is not in the right direction, because our right direction would be that the y-axis would be would represent basically where our periodicity in which direction it is. To define it, we need to basically make some modifications to the direction of the axes, and we can do it by clicking on the coordinate system and rotate, transform basically it. To do that, we could, for example, rotate on the z-axis by 90 degrees. Basically just write in it 90 degrees, and after it click on the rotate x-axis with 90 degrees too, and we get it right. Yeah. Now define the symmetry regions. Basically click on the plane that is a symmetry region and define it with our coordinate systems, which is normal to this plane. And you need to choose which is the symmetry normal. Do that with the other one too. And now let's define that how should it be rotated basically to represent the whole part. It is not only the question of visualization. Our model is ready. So we need to choose here the polar, num repeat for example 6 if we want to see our whole thing, and to 60 degrees if you want so because we use 6 repeats, we need to write in 60 degrees. And choose from here the coordinate system for that we just defined, because we need a polar coordinate system. Create a mesh with 8 millimeters of body sizing, and we can see that it gives back the original model, but with 6 times less element numbers. So I usually like it better if there are less num repeats, because then I see the inside. And let's define our boundary conditions, which is a force through these guys, 1000 newtons, and the cylindrical support through these guys. Yeah, and click on solve. And we can see here basically that it created num repeats with the results files too. So like, yeah, I will turn off the mesh to see it better. And we can, for example, even choose to use only 2 num repeat, but basically that is all that is important. So in today's episode we learned how to make a periodic analysis and an axis 2D axis symmetric analysis. From the 2D analysis there are some other analyses. For example, like we can make plane stress, plane strain, but they are usually much easier. The plane stress is usually used when the third dimension is not really does not really matters. So basically that's all about the beginner course. With these courses completed, you should be able to do an structure analysis of a usual 3D or 2D part. And in the intermediate course, we will talk about how to use assemblies, how to define a bit more complex structure simulations, and for example, how to apply thermal loads or import loads from CFDs. So thank you for watching this course, and bye.